Hello, and welcome to the second part of our review lesson in our fourth unit, Graphing Quadratics, for our grade 10 academic math class. So we've done two examples already. We're just going to continue with another one a little bit farther down the line. So this version of a quadratic, we need to be able to identify what version of a quadratic this is. And this is going to be standard form. Now, how do I know this is standard form? Standard form has no brackets. That's how I can identify it. Now, standard form, as you know, gives us the y-intercept, which is right here at 0, 11. So let's put that guy on right now. There we go. That's going to be 0, 11. It also tells us the direction of opening, so our a value here is a positive 1, so we know our parabola will be opening up, and it will have a plot pattern of 1, 4, and 9. The question requires us to find a vertex, however, so there's lots of different ways to do this. This particular question is offering us an opportunity to complete the square, so we're going to do that just to practice. So completing the square starts with y equals, well, I'll just do a rewrite here, plus 8x plus 11. That's just a rewrite of our equation. And in order to create a perfect square, what I need to do first is common factor out the a value. So the a value here is 1, which leaves us with x squared plus 8x. So fortunately, nothing has changed there. The next thing we're going to do is actually create the perfect square piece. And that means we're going to be adding a value, subtracting a value, and there is our plus 11. Now, what is that value going to be? Well, as you recall, I'll just do a little shout out here for what that value is going to be. The way that we figure out what goes in here is we take our b value, which is positive 8. We take positive 8 and divide it by 2 and then square it. This is procedurally how we go about creating a perfect square. So that's going to give us 4 squared, which is going to give us 16. So 16 is going to be the value that we put into the equation in order to create our perfect square. So that's why we added the plus 16. The plus 16 is there to create the perfect square for us to factor. The negative 16, as you can recall, is there to balance the equation. We can't just add 16 willy-nilly all over the place. It has to be balanced. So then subtracting 16 keeps the equation balanced. Our next step now is to remove the negative 16 from the bracket so that we can go about factoring. And the way that we do that is to get it out of the bracket by multiplying by whatever it is the a value was we had factored out. In this case it was times 1, so that doesn't really change a lot for us, which is nice. So our next line then is going to read y equals 1 x squared plus 8x plus 16. And now outside of that bracket we have our minus 16 and our plus 11. So now we're going to both factor and simplify here at the same time. So we have y equals 1, and now that we're going to factor this, what we're looking for is what multiplies to plus 16 and adds to plus 8. We know it's going to be a perfect square, so we know that it's going to start with an x. It's going to have a plus because we have a plus in front of our b value, and this is going to be 4. And then we simplify the constants on the outside, the negative 16 and the plus 11, which gives us minus 5. So our vertex is going to be negative 4, negative 5. Again, it's the opposite of how it appears in the bracket. So it looks like a positive 4 is actually minus a negative 4. So let's get that on the graph too. Negative 4, negative 5. That's going to be hanging out down here. All right, so now we have our vertex. We can get our axis of symmetry going on. So all the way top to bottom through the vertex. Off we go. Trying to make it neat-ish. And let's label that x equals negative 4. So from here, we're going to apply our plot pattern. And as I said, our plot pattern is always 1, 4, 9 for when we go 1 out in either direction from our vertex, 2 out in either direction from our vertex, 3 out in either direction from our vertex. Now what's interesting is on this graph we actually have an opportunity to go 4 out from our vertex and actually have it on the graph. So I want to remind you that the way we built the 1, 4, 9 is that we were going up however much we were going out, but squaring it. So 1, 4, 9 were for when we went out 1, 2, or 3 steps from our vertex. If we were to go out 4 steps from our vertex, we would then go up 4 squared, which would be 16. So we actually have a chance to do this on this graph, which is kind of nice. These will, of course, all be amplified by our A value. Our A value in this case is 1, so it doesn't change anything. We end up with 1, 4, 9, and for maybe the first time, 16. So let's start graphing. Out 1, up 1. Out 2, up 4, 1, 2, 3, 4. Out 3, up 9, so that's 5, 6, 7, 8, 9. And the partner over here. And up 16, so 10, 11, 12, 13, 14, 15, 16 puts us all the way up there on 11. I'll put the partner over here. So that is our completed graph. Let's put a line through it as curvy and nice as we can. Up, whoop, missed some points on that one. Up we go. Let's get some arrows on there. Not my neatest graph, that's for sure. So we've labeled our y-intercept, which is great. Our x-intercepts don't go through even integers, so we're going to dodge those. And I'm going to label my vertex and the equation. So the vertex was -4, -5. And the equation was y squared, or y equals x squared plus 8x plus 11. So there we go. That is how we complete the square by way of finding the vertex so that we can graph this standard form quadratic. Okay, one more example here. Now this is, well, I guess the first thing we want to know is what form is this in. This is in factored form. And we recognize factored form because there are brackets not squared. So there are definitely bracket or brackets. In this case, there's only one. A lot of people get thrown by that. There's only one bracket. It doesn't change the fact that this is factored form because it's brackets, but they're definitely not squared. So there's no squared happening there. So brackets not squared. I'll rewrite that in a slightly different way so maybe you can visualize that this is actually y equals 1/2 x plus 0, x plus 6. So that they would collapse this down to just be a single x, but it doesn't change the fact that we have two distinct zeros here, and those zeros are going to be 0 and -6. So let's pop those on the graph. There's 0, there's -6, so that's looking pretty good. Visually, we can see that our axis of symmetry is going to be halfway between them at -3, so let's just dot in our axis of symmetry, give it a label. X equals -3. And now we can figure out where is our vertex going to be. In order to do that, we are going to substitute into the original equation the value of our that's crazy. The value of our axis of symmetry. So that's going to be 1/2, and that's our -3, and then this is -3 plus 6. And let's work our way through. So that's going to be 1/2 times -3 times 3, and that's going to give us -9 halves, or -4.5. So that's a little bit gross, but let's get it on the old graph. So -4.5 is going to work for us. So there's -1, 2, 3, 4, and 0.5 puts us right there. So let's talk plot pattern here quickly before we get going. We are going to go with 1, 4, and 9 for our ±1 from the vertex, ±2 from the vertex, ±3 from the vertex. Let's also do 16 this time, just for kicks. So ±4 from the vertex. Now this is going to be amplified by our A value. Our A value for this question is going to be 1/2. So that's going to create some different points for our plot pattern. So instead of going out 1 and up 1, we're going to go out 1 and up 1/2. Out 2 in either direction and up 4 times 1/2, which is 2. Out 3 in either direction and up 4.5, which is 9/2. I guess we'll keep them as fractions. And lastly, out 4 and not up 16, but up 16 times 1/2, which gives us 8. So let's get some of these on the graph. Here we have our vertex, so we go out 1, up 1/2. That worked out nicely. Out 2 and out 2. So out 2 and up 1, 2. There we go. out 3 and up 4.5. So that works out nicely. And as you can see, here we are. There's our 1, 2, 3, or 4.5, I should say. And last point, we're going to go out 4 and up 8. So let's hit that out 4 and up 1, 2, 3, 4, 5, 6, 7, and 8 takes us right to there. And we'll put the partner on over here. And there we go. Let's graph it out. So we've got these points nicely through. Let's get some arrows on these guys. Let's label some stuff. So we have the x-intercepts and the y-intercept. Those both happen to be 0, 0, or one of the x-intercepts and the y-intercept. This one here was -6 and 0. Let's hit the vertex. The vertex was -3 and -9 halves, -4.5. And now we've got to label our equation. So our equation was y equals 1/2 x plus 6. So there is an example of the graphing in factored form with the associated work. Hopefully this was helpful for you and you feel comfortable going on. If you have any questions either on the review or from anything in the unit, please don't hesitate, email. I can try to help you via email, and if that's not working, I'm more than happy to make some more videos to facilitate problems you're having with any of the homework questions or any of the questions in the review. So good luck with the review, and good luck with whatever assessment we're going to go with in unit number 4, and before you know it, we'll see you in unit number 5.